Hey guys, welcome back. This is Analyzing Polynomials from Graphs Round 2. This is basically just picking up from video 1, but with more examples for those of you guys who need it. So when we left off in the last video, we were analyzing x to the third minus 2x squared minus x plus 1, and we went through finding x-intercepts, zeros, y-intercept, the end behavior as x goes to infinity, as x goes to negative infinity, the interval of increasing, the interval of decreasing, the interval where f of x is positive, and the interval where f of x is negative. So in this video, we're going to examine a couple more examples, but we're going to start off with this x to the fourth minus 3x cubed minus 2x squared plus 7x plus 2, which is this graph here. So we're going to run through all of our analysis with this graph. As we can see, this graph is a positive even polynomial, so it makes that upward U shape, that concave up U. So let's find the rest of the information that we need. Let's see here. So we want to find our x-intercepts, which from a graph is just where does our graph cross the x-axis? Okay, here, 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 here. Let me trigger the points. So that's here, 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 here. Okay, it's all of those. So that's where the x-intercept is. So here, 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 those four. So we don't need a lesson on what those are. But we might need to look at what the zeros are again. So the zeros of the polynomials are the x-intercepts. Graphically, zeros are x-intercepts. And what I mean by zeros again is if I plugged that in for x into this polynomial, it would equal 0. If I plugged that in for x, it would equal 0. If I plugged that in for x, it would equal 0. Or if I plugged that in for x, it would also equal 0. What this means is this particular polynomial has 1, 2, 3, 4 zeros, and also know it's a fourth power polynomial. Again, these things do have something in common. So the zeros here, let's see, we have 0.331, we have negative 1.58, we have 1.297, and we have 2.952. Those are our zeros. Alright, where's our y-intercept? Let's see, where does this graph cross the y-axis? It looks like it's right there at 0, negative 2. Also, if we plugged in 0 for x, we would end up with negative 2. The y-intercept is 0, negative 2. What happens in this graph as x goes to infinity? So we're looking as we go to the right. Where does this graph go? Let's see, it goes down, then it goes up, then it goes down, then it goes up, then it looks like it's going to go up forever. So as x goes to infinity, f of x, or the function, will also go to infinity. Okay, now what about, let me erase this guy. Now what about if x goes to negative infinity? Let's look at it from the backwards direction, or from right to left. Let's see. We go down, then we go up, then we go down, then we go up, and it looks like we're going to go up, 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 and away forever. So as x goes to negative infinity, f of x also goes to infinity. And that's because, again, we have this U shape. So we're going to go up, up, and away either way. All right, let's look for our intervals of increasing. Let's see, it looks like we're going down, 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 down. Oh, right here, it looks like we're going to start changing. So let's see what that is. So it looks like we start going up here. We go up, we go up, we go up, we go up until we get here. Okay, so let's see what those intervals look like. And intervals, remember, we always care about the x. So this interval is from negative 0.918. So I'm just going to call that negative 0.9 for short. And it goes until here, so we're increasing till 0.8. Okay, and then a union because we're not done. So union, let's see, we decrease, decrease, decrease until here, and then from here on we're increasing again. So let's find out what that point is. So from that point and on, we're increasing again. So that's going to be from that point to infinity. So we'll call that 2.4. So from 2.4 to infinity, we will also be increasing. So those are our intervals of increasing. Let's look at our opposite. Now let's look at our intervals of decreasing. Okay, so it looks like we're decreasing now. So coming in from negative infinity, we're decreasing, decreasing, decreasing until we get to negative 0.9. So we decreased from negative infinity to 0.9 where we started increasing. Okay, union, where do we decrease again? We increase. Oh, from here to here, we're decreasing. Or also, that was just the interval between these two guys. Okay, so that was 0.8 to 2.4. So from where x is 0.8, okay, till when x is 2.4, we're decreasing. And then we're increasing the rest of the way. Alright, where is f of x positive? In other words, where is the function above the x-axis? Okay, so that's just that. That's this piece here, and that's that here. But we have to write it all in intervals. So from negative infinity, actually, let me erase this really ugly circle that I put here. So from negative infinity up until this point, here, we're above the x-axis, below. Oh, from here to here, we're also above the x-axis, below. Oh, and then here until infinity, we're also above the x-axis. So let me trigger those points so we can get all of these intervals. That's here. You'll recognize these points also as being our x-intercepts. So the x-intercepts play an awful lot of roles, and we'll see that when we start analyzing the polynomials from the equation. So we're positive from negative infinity until we get to our first intercept, which is negative 1.58. Negative 1.5. Then we go negative. Oh, positive now from here, from 0.33. So union point, I'm just going to call it 0.3, comma, positive. Oh, stop being positive, 1.3. I'm just rounding these numbers. Union again, and then negative. Oh, we start going positive here, and that's at 2.9. 2.9, and that goes to infinity. Let me squeeze it in there. There it is. Okay. Those are all the intervals where f of x is positive. Again, graphically, that just means where are we above the x-axis. Okay, so the opposite of that is where is f of x negative, or in other words, where is f of x, or the graph, below the x-axis. Okay, well, we're below the x-axis from this point to this point, right? Down. Okay, so that's between our first two x-intercepts. So that's between 1.5 and 0.3. Notice this is just the space between these two guys. Union, where are we? We're positive, we don't care. Negative, we're negative in here. So that's from 1.3 to 2.9. We're negative. And then that's it. The rest of the way we're positive. So just notice these intervals are the in-between intervals of these guys, right? Because if you're not up, then you must be down. So the intervals of negative and the intervals of positive, if we put them all together, they would be the whole interval. Because again, if you're not up, you're down. Okay. All right. So that was a positive even that we looked at. Now let's switch our graph, and we'll take that graph away, and we'll look at a negative odd. So this is a negative odd. This is negative x to the fifth plus 3x to the fourth plus 5x to the third minus 15x squared minus 4 plus 12. It's huge. Okay, so let me erase everything that corresponded to our last graph because no longer helpful. Go away. This is another point where please feel free to fast forward through this ridiculousness. Okay, maybe if I just do a swipe like that, oh, that takes out a lot of it. Go away. I have so many pen strokes. Okay, all gone. Finally. Okay, with this guy, this is to the fifth power, so notice we have a lot of ups and downs. Okay, we have one more x-intercept than we did. This is not going to be all the time, but notice that we have, let's see here, 1, 2, 3, 4. We have 5 x-intercepts, and this is something to the fifth power. Again, this is going to come into play later. To the fifth power, 5 x-intercepts. Okay, I'm not going to write the x-intercepts down because we know what those are. But again, the zeros here, the zeros are just the x-coordinate of the x-intercept. Zeros are, if we plug these numbers in for x, they would create a 0. In other words, the whole thing would zero out. So our zeros are -2, -1, so -2, -1, 1, 2, comma, 2, and 3. Those are all the zeros for this particular polynomial. Okay, next let's find our y-intercept, which I think it's up here. It's up here and it's at 0, 12, because again, if we plugged in 0 for x, oops, let me get my cursor. If we plugged in 0 for x, 0, 0, 0, 0, 0, 0, 0, 0, except for the 12. So the y-intercept here is going to be at 0, comma, 12. Okay, let's go back down. Move this. I want it there. Sorry for anybody I'm making dizzy with this. Okay, as x goes to infinity, what happens? In other words, if I read this graph from left to right, as x goes to infinity, what happens? Well, as x goes to infinity, this graph goes down. So f of x is going to go to negative infinity. Okay, what about as x goes to positive infinity? Or sorry, as x goes to negative infinity, that means as we go to the left, what's happening? Okay, as we go to the left, 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 oh, we go up to positive infinity. So as x goes to negative infinity, f of x then goes to positive infinity, just because as we go to the left, the whole graph is going to go up forever, and up forever is infinity. Down forever, negative infinity. Okay, that's the difference. As we go to the left, do we go up or down forever? And as we go to the right, do we go up or down forever? Intervals of increasing. Okay, this is going to be a big one. Let me, in fact, even make this graph smaller. Smaller? Maybe smaller? Not smaller? Can I? There we go. Let me make it smaller and let me move it over there. And let me also, again, trigger all of our intercepts. Sorry, not our intercepts. I want to trigger our maxes and mins for this. 1, 2, 3, 4, because these are going to differentiate our increasing and decreasing. So our interval of increasing. Okay, so we go down until we hit this point. So this will start our increasing. So again, it's the x coordinate. So we're going to increase from negative 1.6, and I'm just going to shorten all these. Increasing, increasing, increasing up until here. That's negative 0.1. Negative 0.1 union. We go down, we go down, we go. Oh, we increase from here. So 1.5. And then we increase up until 2.6. 2.6. And then we go down forever, never to be seen again. So we're done increasing. Intervals of decreasing. So it looks like we start off increasing. So we're coming in from negative infinity, decreasing. And we decrease until we get to negative 1.6. Negative 1.6. Union. Let's see. Increase, increase, increase. Don't care. Oh, here's where we start decreasing in. Negative 0.1. Negative 0.1. Till decrease, decrease, decrease till here, till 1.5. 1.5. And then union again. Let me move my pen down here. Ha. And then union, let's see, so we just did to here, increase, increase, and then from here on we're going to decrease again, so from 2.6 onto infinity. We're also going to decrease. Right, from here we're going to go down forever. So as x goes to infinity, this guy is decreasing. So the last interval is a decreasing interval. Alright, intervals where f of x is positive is, again, where is f of x above the x-axis, write your interval, and same thing for where is f of x negative, same thing, where is f of x below the x-axis, and write your interval. I hope that helped. please ask questions as needed.